may not be on the handout. I would think at this stage of your math, if you were asked to do this, these markers will work out for me. I have my first one, and maybe on the handout. That looks like this. That's how you solve for x. That's where we're going to get class started. Solve for x. Guys, when I run through this, let me run through this quickly so I can get to the more complicated equations here. To get a start. Why did I bring this in first? Some students may say something about, Professor, you need to do 8x subtract 5. No way. Anyone give me an input real quickly on this first one. What might you suggest I do first in the attempt to get a start?
Distribution.
Okay, you're saying this right here, Professor, be careful. You're saying like a distributive property. So I can rewrite this as 8x, no problem. Now notice there's a negative sign in front there. So it's like a distributive property with a negative 5. So we're going to distribute this on negative 5 times 2x plus 1. Do not let me make a mistake. Will that give me, now let's rewrite. Will that give me that at this point? All I did was the distributive property right here. Distribute the negative 5. Now, I will collect like terms and put these two together. All this should be fairly basic. That's a negative 2x. Subtract 5. Still equal to this. Now, across the street to at that middle school where the kids are doing this. Now, to solve for x, usually we try to get the x's together. I don't care which side you bring the x's to. If I bring this one over by subtracting, that's when I end up with a negative 5x. That's no problem. If I bring this over by adding 5, what is it? Negative 10 plus 5 gives you what? Is that negative 5? Yes or no? Yes. The way I'm going to go. And quickly the answer is 1. Positive 1? Divided by negative? Yeah. Usually we check these. Usually I take the time to put an answer back in, check it, and see what's going on. Now, before going further, I did not tell you my little routine for class. Some students come in, there are no cell phones being used in here for class, in class. Also, we all take a break at the same time. I've seen some professors where some students are standing in the hallway and I think, don't they have class? No, they just walk out. The professor just continues. Students just go, walk out on their own. You don't do that here. We all take a break at 4:30. Get that 15-minute break. Guys, there's the first one that I looked at there, and I thought I'd bring that in. Now, that's classified as, I'll do this. That first one's classified as, it came out to be a linear equation. A linear equation. Now, they want to tell me why, I finished it up, I got the answer. Why might, just by observation, we first glance at it, why might you classify that as a linear, and what is linear? What other equations are there out there? Quadratics.
Exponential.
So again, here's something else.
Exponential.
Yes. There's lots of different types of equations. Why would I know as a student here, Professor, you will get one answer? Not two, not three, only one answer. And it's classified as a linear. What might that word linear mean? Yes.
It has one solution.
As one solution. As one solution. Your textbook says, if it looks like this, they made it really easy. AX plus B is equal to 0. That's x. They want you to solve for x. Anyone in class at this point would know if you want to solve for x, you're going to end up with x is equal to a negative b over a. You're finished. So they're saying if it looks something like this, and finally, guys, mine down here would, I can make it look like that. Down here near the end, I'll be like this. linear, you expect one answer, you get that one answer, you should check it to make sure it is correct, you didn't make a mistake. It's called a linear equation. Now, the ones that are a little bit more difficult, though, to deal with, and I heard the word, are these. A quadratic equation. Now, what might one of those look like? Your standard form looks like this. Ax squared plus bx plus c is equal to 0. Big difference in the linear and the quadratic. I see right here, my exponent understood on the x there, that exponent is understood to be a 1. What's my exponent here on the x on the quadratic? 2. This tells me what? A quadratic should give me what? 2 answers. If I have a 3 here, we get 3 answers. This is called a cubic. If I have 4 there, we'll get 4 answers. A quartic. We're going to be concerned with a quadratic. For the remainder of this section on the equations here. Hey guys, if I have a few here to look at with you, I brought in this one. X squared subtract 5x subtract 24 is equal to 0. Now I need some input. You see that? You say, Professor, it looks much like this one. You said it's called a quadratic. It is called a quadratic. I'm expecting, and this is called the degree. Let's put some vocabulary there. This is my degree. I'm expecting 2 answers. Does anyone recall how to find the answers for a quadratic? It's not linear. Yes, go ahead.
You could do guess and check.
You're going to guess and check. In fact, I'm looking for a key word when you say guess and check. Factor. Now, some students have strong factoring skills. Some do not have strong factoring skills, but the student said to the professor, you need to do this for one approach. You need to factor this. Now, some students may be sitting there and say, Professor, I see those factors right quickly. I know how to factor that. And you guys who see it right quickly do not make a mistake. Is it x and x for a start for the x squared? Does anyone know what should be placed here to make this quadratic work out for me on this one? I see your hand going up, yes?
-8 and 3.
And a positive 3. You guys agree? And if I multiply this out, and so many students can multiply this out, right? Some students come to my classes and they say, Professor, I saw this back in high school, they call it FOIL method. Or I've seen some are just wanted to use distributive property somewhere. And it works out. Absolutely. Now, a quick check I would do this right here. If I place those numbers correctly that he gave me, this much right here for a product is negative 8x. This product is what? 3x. If you combine those two, like terms, negative 8x and 3x, you get negative 5x. Like they wanted you to get. Absolutely. Works out. Now, am I finished? I don't have the answers yet. Now, I heard students say, Professor, there's a property called zero product property. What am I allowed to do? I'm allowed to set each one of these factors equal to 0. Why? Well, the product is 0. I see 0 on the right-hand side. Go ahead and solve this, and we end up with 8. Go quickly, and down here looks like a negative 3. Guys, I will not take time to check these right now. So my quadratic, my first quadratic, looks like this. I have an 8 and a negative 3. I like to place my set notation there. And I'm finished, got the answers. No problem. Now, before I go any further, that's my first one I want to point out. I have a plan for this. On the side here, maybe I should put it in green. Here we go. We use the technique on this one of factoring. We factored. Now, can someone tell me another method you've seen somewhere that you could have applied here, not factored, and got the same answers? okay, not group, something else, yes.
Quadratic formula. is
Quad-
the same.
hang on, quadratic formula. He says, professors, it's a quadratic, so I remember there's a quadratic formula. I agree. And some students love the quadratic formula because, like I was back when I was a student, my factoring skills were not the best. My factoring skills were not the best, so if it's not, I applied the quadratic formula. Now, what is that formula? X is equal to negative b plus minus square root. Yeah, b squared, subtract 4ac. There you go, all over 2a. I guarantee if I based my grades, I had post grades tonight, let's say the class ended tonight, I should have all A's posted for a final grade. All this. Guys, there's my quadratic formula. I'm going to do this just in case. I'm going to apply that green formula to this. I know we have solved it already. Do I get the same answers? Well, let's see if I do. X is equal to, now I need to identify the A, B, and C. Well, it looks like the A should be the coefficient of the x squared, the B, the coefficient of the x, and C for constant, is my constant. But my A is 1 in this case. So it should be a 1. B is a -5, C is a -24. If I'm careful and put that in, it may look a little awkward, but here goes. It's going to be a negative, -5, plus minus, square root, -5 squared, subtract 4 times A, and I think we said A back here, my leading coefficient back here, which understood to be a 1, that's A. And my constant, the C on the end, was -24. All over 2 times A, 2 times 1. Looks like, bring up here so everybody can see it. Let's see if it's going to work out. I'm going to end up with a positive 5, plus minus. Guys, that part underneath there bothers me. It's a mess. It's that. Now, what is that? Well, I know the first part, -5 squared, I think we all know what that is. That's 25. The end part, let's put 25 in there. Now, when I say the end, I'm talking about this. I'm taking all that and work it together. What's left over? And what's left over is a -4 times 1 times a -24. That's what is that? Positive 4 times 24. What is 4 times 24? 96. And all that's still over 2 times 1. I see down there that 2 is still there in that quadratic formula. And if I simplify this further, 5 plus minus. Guys, underneath there's a strange number, 25 plus 96. Help me out. Is that 121? If I add them up, is that 121? I think. Over 2 here. Now I got a square root of 121. Is 121 a nice perfect square root? Is it 11?
Yeah.
So write this as -5, positive 5. 5 plus minus, thank you, this is perfect, it's 11 over 2. If I now consider this split up, one answer looks like this, 5 plus 11 over 2, which I think is 16 over 2, which is 8. And by the way, it was 8, one of the answers back here. The other one separated is 5 subtract 11 over 2, looks like it's going to be a -6 over 2, or a -3. And checking back, looks like a -3 came out earlier. So that quadratic formula is going to work for me. So my factoring skills, unless you're required to do it by factoring, then students may say, Professor, can I go to the quadratic formula? Why not? And use the quadratic formula to see what's going on there. So that's another technique. Let me go back to the green. Does anyone think they know another method which is maybe a little bit lengthier, but it'll work to solve, I got some squeezing right here, number 3, to solve a quadratic besides factoring and besides the quadratic formula? Yes,
Completing the square.
completion of the square. Well, let's careful on this. This is the one that many students will stay away from, but it works. In fact, I insist students do some by completion of the square. So guys, factoring, we did one quadratic formula, we did one completion of the square. You have not seen that process yet. And to get into that process, I need to point out a few things about where this completion of the square comes from. First, let me ask you underneath here. Suppose you were asked to solve this. X subtract 2, quantity squared equals 49. And you were asked to solve it. Can anyone tell me a quick way to solve it? Give me a method, something you could do with that equation to end up with the answers. Yes?
Take the square root of both sides.
If you take the square root, I see a square, he says, well, Professor, undo that square by doing this. Do a square root. But you gotta do it on each side. Well, the left-hand side's nice. It's just merely x subtract 2. The other side, also nice. What's the square root of 49? 7. Now, why, someone tell me in class, why must I, in this case, not always, why must I prefix this with plus minus? Because square root of 49, just square root of 49 is 7. But why, in this particular case, must I put a prefix there, plus and minus? Yes?
Negative is supposed to make positive?
No, something else. Something else, based on what we're doing here, yes.
Because the x plus 2 would be plus 7 or minus 7.
Something else. I understand what you guys are saying, you're saying correct, something else, so y plus minus, because we walk out of here and say, Professor Ramsey says square root 49 is plus and minus 7, that's wrong. If someone after class says square root 49, this is all they do, you had better say 7. That's what it is. By definition, you see just square root 49, the answer is 7, not plus minus. Why must I, in this case though, put plus minus? Yes? Because the degree is 2, which implies how many answers must I get? 2. I won't get 2 answers unless I put plus minus. That's the only time I do it. Now to solve for x, move that 2 over by adding. Good response. You will end up with 2 plus minus 7. And it looks like if I split those up, guys, one answer is going to be what? 2 plus 7? I guess was it 9? And the other one's 2 subtract 7. Is it negative 5? If I made no mistakes. So this up here in blue, the solution is, if there's no mistake there, 9 and a negative 5. Would you guys agree? Easy check though. Go back to the blue and do a replacement. Those both those ones will check. Now, I led you into it. Made you feel good. It's one thing professors usually do on the first day. Even in grad school, when I was in grad school, the first day was so nice. I love grad school. I've done my undergraduate work, now I'm in grad school. I'm at the top. First day is always, professor comes in smiling, and all of a sudden they get you all engaged and say, oh, this class is going to be something else. I love this class. All we're doing on the first day is 1 plus 1. That's 2. You know, so something else I recognize on day 1, they bring back things in, from memory of things like I'm trying to do with you guys. Then all of a sudden it hits you. Oops. There's something there I don't understand. Right now, though, we understand. Just gradually going there. I'm going there slowly. Wait till you see what's going to happen. Guys, we got, here we go, factor, if you can. Quadratic formula, go for it. Completion of the square, yes, and I'll probably insist on some thoughts being done by completion of the square. A little lengthy, can be done though, and they'll all lead you to the same answers. I don't care which technique you use. Now, just out of curiosity, those in the room there, those are the only 3 I'll be using. Does anyone think they know another method that might be used to solve the quadratic besides factoring, quadratic formula, completion of the square. Where else, maybe some students have witnessed it somewhere previous. Professor, I know another way to solve the quadratic besides those three methods you have on the board. Yes, sir.
Graphing.
Tell me again.
Graphing.
Graphing. Now, I'm not gonna do it now, but since he mentioned graphing, just real quickly, to do graphing, and we're on the first day of class here, does anyone recall what a quadratic should graph into to begin with? A parabola. A picture of a quadratic is a parabola. Now, the parabola can open up, open down, not sideways. We're talking about functions here. Open up or open down. Now, for example, that last one there, we try to find where on earth we were with all this beautiful work we've been doing here. We got what, a +9 and a -5, I think it was, for answers on this one. That's what we got? All right, let me go back to this one. We got what, a +8 and a -3? Yes, what's happening? If you saw the graph, a picture of this equation, function here, x squared subtract 5x subtract 24, you snap a picture on your phone, it's gonna look like this. And it's gonna open up. There's a quick glance at the picture of this. Now, where does that graph intersect the x-axis? At what numbers? +8, and what's +8, one of the answers? Where else does it intersect or cross the x-axis? -3 was -3 also. Now, wouldn't it be nice on Wednesday that I had on each quadratic on the quiz? Wouldn't it be nice if I had a picture of the parabola and showed you exactly where they cross the x-axis? And ask you to please give me the solutions? Wouldn't that be nice? All you'd have to do is what? Look at the graph? Say, Professor, are you kidding? I love this class. There's the answers. Do you think I'm gonna do that for you? No. You don't want to supply graphs. That graph will come up to later on another chapter in this textbook. We're gonna be concerned about can you do that? Factor, quadratic formula, or completion of the square. You get the answer. You guys will be moving into, hang on here, part 2. Then we'll slow down and look at some of the exercises on that handout. If you got a chance to look something with me on the handout. I need to look at this with you. Here goes. I get a sense the class is ready for it. Yeah, we should be. Okay, solve. I like to solve the equation.